Hello my dear students, today we will discuss about shear stresses in beams. In the previous chapter we discussed the theory of simple bending. In that theory, we assume that no shear force is acting on the section. But in actual practice, what happens when a beam is loaded, the shear force at a section always comes into play along with the bending moment. It has been observed that the effect of shearing stress as compared to the bending stress is quite negligible and is not much importance. But sometimes the shearing stress at a section assumes much importance in the design criteria. So in this aspect, we will discuss how shear stresses are developed in the different types of cross sections. Okay, so first we know what is shear stress. This all of you know what is shear stress. Now you have to, these are the stresses developed in order to resist the shear force, that is the shearing stress. Shearing means there will be a sliding effect, I have discussed these things in the first unit. There will be a sliding effect on the block, so each blocks are slides each other. So in order to avoid that shear force or shearing, the stresses are developed, that is called shear stress. So shear stress is given by this equation. Tau is equal to F into AY bar divided by IB. Okay, this is the standard equation. The derivation is there. I am not explaining that because it is not required for you. Okay, you just remember this formula, how to find the shear stress. So shear stress, that is tau, is equal to F into AY bar divided by IB. Here F is shear force, that is in kilonewton or newton. B is width of the section, okay, and that is in mm, and I is moment of inertia of the section about its neutral axis. Area, A is area, and Y bar, that is distance of CG of the area from the neutral axis. Then tau is shear stress, that is in Newton per millimeter square. So this term you should know while solving the examples and also this formula. Let us see one by one. The first we will see the distribution of shearing stress over a rectangular section. Now I will consider one rectangular section of width B and depth D. Okay, for this, this is the standard formula. Tau is equal to F into AY bar divided by IB. Here for the rectangular section, the terms you have to think according to that, the term gets changed. Now here a shear force, that is at the section. A is area of the section, above Y means this portion. Okay, area of this portion it is asked, that is above Y, and Y bar is distance of shaded area, that is from the neutral axis. Then AY bar is moment of shaded area about the neutral axis, and I is moment of inertia about its neutral axis, and B is width of the section. So when it is asked to draw shear stress distribution diagram for the rectangular section, you have to draw like this. At the uppermost layer it is 0, and at the bottommost layer also it is 0. It is maximum at the neutral axis. You can see here this is maximum neutral axis. Diagram only you can make out. Here at the top layer it is 0, bottom layer also it is 0, and it is maximum at the neutral axis. Okay, now this, suppose if it is asked to find at different points, now it is showing that it is to find the shear stress at this point. So it is calculated that you can calculate it based on these values. Okay, so maximum is always at the neutral axis. In the case of rectangular section, it is at the center. Now we'll see what is the formula for that. See, tau maximum, that is equal to 1.5 tau average. Here also there is some derivation. I'm not explaining that. Okay, you just remember tau maximum is equal to 1.5 times of tau average. What is this tau average? Means average shear stress is equal to shear force divided by area. F divided by area. F area for the rectangular section, that is BD. So tau average is equal to F divided by BD. Okay, so how you can calculate tau maximum? That is equal to 1.5 times of tau average. So calculate tau average using this formula, shear force divided by BD. So always you should remember maximum shear stress will be developed at the neutral axis, that is 1.5 times of the average shear stress, that is in the case of rectangular section. Okay, so we will solve one example on this. A wooden beam 100 mm wide, 250 mm deep and 3 meter long is carrying a uniformly distributed load of 40 kN per meter. Determine the maximum shear stress and sketch the variation of shear stress along the depth of the beam. So it is asked to draw shear stress diagram, and it is given that it is a rectangular section of width B is 100 mm and depth is 250 mm and the span is equal to 3 meter. So you can write in terms of this millimeter, so that is 3 into 10 raised to 3 millimeter. Okay, here this is missing. Just write here, this is 3 into 10 raised to 3 millimeter and uniformly distributed load, that is W, given as 40 kilonewton per meter or 40 newton per millimeter. Okay, this is 10 raised to 3, 40, right, and millimeter to millimeter 10 raised to 3, it get cancelled, so it becomes 40 newton per millimeter. Now we will see first we have that formula, maximum shear stress is equal to 1.5 times of tau average. So first we'll calculate what is tau average. To find tau average, we required tau average is equal to F divided by area. So F, that we have to calculate. So that we will calculate first shear force. Shear force, all of you know now, you have studied shear force diagram and bending moment diagram. In that I have told what is shear force for uniformly distributed load when it is a simply supported beam. It is not given here which type of beam, so let us consider it is a simply supported beam. Okay, so it is a simply supported beam and subjected to the UDL, the maximum shear force is given by WL divided by 2. You should know all these things. Okay, so F is equal to WL divided by 2. So what is W? It is given here 40 into L is 3 into 10 raised to 3 divided by 2. So you get 60 into 10 raised to 3 Newton. Okay. Now because I have here it is converted 40 Newton per millimeter square, so 40 Newton, and this is also in millimeter, so 3 into 10 raised to 3 millimeter, so divided by 2 you get 60 into 10 raised to 3 Newton. This is the first step. After that you have to calculate area of the section, because tau average is equal to F divided by area, shear force divided by area. What is area? Area for the rectangular section is equal to B into D. What is B? B is equal to 100 and D is equal to 250. So 25,000 mm square. Now calculate average shear stress. So tau average is equal to F divided by A. F is equal to calculated value 60 into 10 raised to 3 and divided by A is 25,000. You get F tau average is equal to 2.4 Newton per millimeter square or 2.4 MPa. Now let us calculate what is maximum shear stress. What is that? I have told tau maximum is equal to 1.5 times of tau average. So that is equal to 1.5 times of tau average is equal to 2.4. So into 2.4, that is equal to 3.6 MPa. So this is maximum shear stress. So very simple. You should know the relationship between for the each cross section. For the rectangular cross section, tau maximum is equal to 1.5 times of tau average. So tau average is equal to shear force divided by area. So area is equal to B into D. Shear force is equal to, it is given uniformly distributed load, so shear force is equal to WL divided by 2. All values are there. You have to just calculate and simplify. Okay, so in this way you can calculate what is maximum shear stress in the case of rectangular section. Let us take now now you have to draw shear stress distribution diagram also. This is a rectangular section and diagram comes like this. It is 0 at top and bottom layer and maximum at the neutral axis. Okay, next let us take distribution of shearing stress over a circular section. Now for the circular section, shear stress distribution diagram is like this. Now this is the diameter and same like rectangular section only here also. At the top layer and bottom layer it is 0 and it is maximum at the neutral axis. Here in the case of circular section also it is at the center. So if it is asked to find somewhere here above 1, you have to calculate what is the shear stress value here. Okay, here this tau maximum is given by the relation or equation 1.33 into tau average. How it is for rectangular section, tau maximum is equal to 1.5 times of tau average. Like that for circular section, tau maximum is equal to 1.33 times of tau average. How to calculate tau average? That is same thing, F divided by BD. So that you have to calculate, and this is the general formula for the shear stress. If it is asked to calculate somewhere here, then you have to use this formula. This is only for the maximum, that is at the neutral axis. Suppose if it is asked to calculate here, then you have to use this formula. Same thing applies to rectangular section also. Okay, these are the same terms. Tau is equal to shear stress and F is shear force, and AY bar is moment of shaded area about the neutral axis, radius of circular section R, and I is moment of inertia of the circular section, and B is width of the strip. Okay, now we'll solve an example for this circular section. A circular beam of 100 mm diameter is subjected to a shear force of 30 kN. Calculate the value of maximum shear stress and sketch the variation of shear stress along the depth of the beam. Now here what is given, diameter is given, that is 100 mm, and shear force value is given here. F is equal to 30 kN or 30 into 10 raised to 3 Newton. What you have to do now, first let us calculate what is the area, because you have to calculate maximum shear stress. So maximum shear stress is equal to 1.33 times of tau average. Tau average is equal to F divided by A. So F is given, area is not given. So first calculate area. What is area for the circular section? Pi divided by 4 into D square. So pi divided by 4 into D is here, it is given 100, so 100 square. So you get area is equal to 7854 mm square. Next you can calculate, you have shear force value, no need to calculate here. So you can calculate what is shear average shear stress, that is tau average is equal to F divided by A. So substitute F is equal to 30 into 10 raised to 3 divided by 7854 area, that is equal to 3.82 Newton per millimeter square, that is equal to 3.82 MPa. Now you can calculate what is maximum shear stress, that is equal to tau maximum is equal to 1.33 times of tau average, 1.33 times of 3.82, that is equal to 5.08. Okay, so this way you can calculate what are the shear stress value at here it is asked to find at the center, maximum will be occur at the neutral axis, you can calculate. So now you have to draw the diagram, shear stress distribution. So it is 0 at the top and bottom layer and maximum at the neutral axis. Okay, that is equal to 5.08. So this is about circular and rectangular section. The next class will discuss about T section and I section. I just show show you how to draw I section, shear stress distribution for the I section. Same thing, it comes like this here, and here also maximum shear stress will be located at the center. This is for I section, and for the T section, this is the T section here, like this. It is maximum at the neutral axis. Here neutral axis you have to calculate where it lies, that is here in this case. So maximum at this point. Okay, so regarding this I and T section, we'll solve I will be solving the examples in the next lecture. Thank you.